Alcoholic beverages have been enjoyed by many cultures for thousands of years. The earliest alcoholic beverage found to date was found in Jiahu, in the modern Yellow River Valley in China. It was found to be a mixture of fermented rice, honey, and hawthorn fruit or grape. Residues have been dated to around 7,000 to 6,600 BC, and these residues were contained in pottery jars. Now, pottery has played a key role in the development of large-scale settlements. However, the development of a storage economy was also a key element in the evolution of hunter-gatherer societies. In pre-ceramic times, hunter-gatherers would have made use of naturally occurring objects, such as animal skins, gourds, large shells, wood, or bark fibers to fashion bowls and baskets. Hunter-gatherers have also been documented to use these storage pits to store their goods. These are sort of holes dug in the ground which would have been lined and sealed to provide an airtight environment. Storage pits and pottery vessels, as well as other methods of storage, may have provided a really good environment for fermentation to occur. This is because fermentation will only occur under anoxic environments, so a lack of oxygen. The yeast, which produces the alcohol, will only produce alcohol in the absence of oxygen. Now, for my experiment, I will be studying how pottery affects the fermentation rate, and I'm doing this because, according to the literature, pottery was used by hunter-gatherers in order to cope with the changing environment, resource scarcity, and to increase nutrient extraction via cooking and storage using pottery. So the aim of this experiment was to determine the rate of fermentation of grapes, cooked barley and honey, and to compare them in order to determine what may have been the first accidental alcoholic beverage. I was also investigating the use of earthenware pots as vessel types and to see if the use of them has any effect on the natural fermentation of the different sugar sources. So for the materials, I used 3 plastic buckets, 6 glass bottles, 3 earthenware pots, some cheesecloth, baker's yeast or Saccharomyces cerevisiae, some duct tape, 6 sets of plastic tubing, raw honey, red grapes, and raw barley. I also used a hydrometer in order to measure the specific gravities of the original mixture versus the final fermented mixture. Alright, now on to the methods. There are a few things I had to do in order to actually prepare the mixtures for fermentation before they could actually ferment. For example, the honey. Honey is a natural antimicrobial, so in order to actually enable yeast to grow in it, I had to dilute it with water, and this is to decrease the osmolarity or the sugar content, and also alleviate the low pH in the solution because it would be just too low for the yeast to grow in that. For the barley, I cooked it for a little while. This was just to sort of try and release the sugars from the barley and sort of break it down a little bit so that yeast could actually digest what was in the barley. This is something that you'll probably try and do when you're brewing beer. You'll malt it, which just means that you, at the end of the malting process, basically, there'll be enzymes which break down the starch in the barley into just basically into glucose that the yeast can digest. For the grapes, I had to just break them up a bit, mash them up, so that there was sugar in the liquid. I put a little bit of water in there just to increase the amount of juice I had, and that's not a problem because I'll just be measuring the relative decrease in the sugar at the end. And I put a little bit of the skin into the fermentation vessels too, because yeast actually grows on the skin of grapes, and so I was trying to make sure that yeast got into those vessels. Okay, so what I actually did for the experiment, I used the same original mixture for each of the experimental samples, and then I measured the specific gravities of each of those mixtures so I could measure the start and finish specific gravity and compare them. Then for my control sample, I added Saccharomyces cerevisiae to a portion of all my mixtures and put that into a glass bottle. I put a plastic tube into the glass bottle so it was sticking out of the mixture so it wasn't inundated in the liquid. And then I sealed the bottle top around the tube with duct tape. I poked the other end of the tube into a container full of water just so the air could bubble out from the tube and not let any air in. Then I let that mixture sit for 19 days. For the experimental samples, I left the remaining mixture out in buckets, covered loosely with cheesecloth, next to an open window for 3 days. So after 3 days, I poured the liquid either into a glass bottle, just like what I did with the control, and I sealed it and put that tube into the water, and or into earthenware pots. And these pots were pretty porous. They kind of let air in and out. I sort of had liquid seeping out of the pots at the end of the experiment, so I knew that there was a little bit of airflow in those pots. So after 17 days of fermenting my potted and bottled aerated mixtures, I uncovered them to see what they looked like.
Go. That looks disgusting.
It smells alcoholic.
Oh man, don't know what. Go.
Okay, here we go. Oh.
Oh no, that's got alcohol. Oh Sophie, that looks disgusting.
Oh,
sorry.
Oh. So as you saw, my mixtures look pretty disgusting. They smelt very alcoholic, but not a very palatable alcoholic smell. Alright, so onto the bottled samples now. You can see with the bottled barley samples that there's a massive difference between the baker's yeast sample and the hopefully naturally fermented yeast sample. Yeah, there's a massive colour difference. The one on the left just looks a little bit disgusting, to be honest. They both smelt pretty similar. The one on the left might have been a little bit more offensive smelling. Similarly, the honey had a little bit of a colour difference between the baker's yeast sample and the hopefully naturally fermented sample. Both smelled pretty similar. The only thing to note about the fermented honey mixtures was that the one that I put the baker's yeast into actually got a little bit effervescent, so it was a little bit fizzy. Now, the grape samples, they both looked very similar to each other, both in the smell and the look and the opacity and everything. So that might have had something to do with the fact that yeast grows on the outside of the grapes naturally. Now just to look at a more graphical representation of results, the grapes showed the most consistent results. All of the fermentations showed a moderate decrease in sugar. They're all the same. This also may have been due to the fact that the yeast is naturally present on the grape skins, so they may have all fermented in a very similar fashion. Now for the honey, in the pot, the naturally fermented honey did not have much of a decrease compared to the other trials. That may have been contaminated, or it may have been due to the evaporation of moisture from the container. And the cooked barley actually saw an increase in the sugar levels. Not sure what happened there. Some sort of contamination, I presume. And the other samples in the bottles saw a similar decrease. So you can definitely see that potting the mixture had an impact on fermentation. The potted mixtures saw an increase in the degree of variability for honey and barley. Not for grapes, probably just because of the yeast that was in there already. So this may have been due to contamination. There were definitely more consistent results though when the mixture was completely airtight in the bottles. So how can these results be used by archaeologists to interpret the archaeological record? Honey would have required water to allow yeast to ferment, of course. Barley needs to be cooked first, and grapes are probably the most promising for the accidental fermentation event to have occurred because they have yeast naturally. They're juicy, and in this experiment, they have the most consistent results, including in the pots. So just from the results I have here, I would say that the more likely first sugar source for fermentation would have been grapes, just because it fermented the most consistently in the pots and also when it was sealed up. So it would have had the greater likelihood of doing a proper fermentation. Archaeologists may be able to use this information to help them interpret yeast ware residues. For example, the presence of grapes in beverages may have been a way for ancient brewers to introduce yeast into the mixture to ensure that it fermented.